Hey everybody, this is Mr. Beckstrom, and I wanted to go over that problem that we were working on yesterday. We kind of ran out of time, and I got a little bit flustered after that phone call, so let's go ahead and go through the whole process of this here. So once again, we're starting with a third degree polynomial. That means that the highest degree in this polynomial is a 3, and we're trying to find the factors of it. Basically, if we set this equation equal to 0, which I'm going to do right now, oops, 2x cubed minus 3x squared minus 11x plus 6 is equal to 0. If we solve this equation for x, we're going to find that we're going to have up to 3 real solutions. And that's possibly 3 different places where this function will cross the x-axis. One thing that I like to do, and I didn't do this in the class because we were kind of running out of time, but I like to put the equation in my calculator here. So that's going to be 2x cubed minus 3x squared minus 3x squared minus 11x minus 11x plus 6. And if I put this into my calculator, and let's go ahead and go do a zoom, and we'll start with a standard graph. We'll see that we can already see that it goes through the x-axis here, here, and here. Now it looks like negative 2 is one of our roots here, and it looks like positive 3 is probably another one. And we're not quite sure what this is going to be. We can use our trace function if we want to get real close to it. It looks like it's getting close to 1/2. The x equals 1/2 there. So this just kind of gives us an idea of what they should be. But what we're going to do is we're going to use the rational zero theorem in order to solve this. And the way we do that is we take all the factors of the last coefficient, that's the constant. We're going to call that P. And we're going to also take all of the factors of the first constant. Or the first coefficient, which is in front of our highest exponent term. We're going to call that Q. And then we're going to look for all the factors of P divided by all the factors of Q. And if we have rational zeros, that means rational numbers, x values that this curve goes through, it's going to be located at one or more of those points. So all the factors of P, we have 6. And we're going to look at both the positive and the negative ones. So 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6, a little plus or minus. So that's really 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different factors for P because there's a positive and a negative version of each of them. Now for Q, we're going to have plus or minus 1. We're also going to have plus or minus 2, so there's going to be 4 total factors for Q. So now we're going to start by putting every one of these factors over every one of those factors. So if I start with the 1 here, I'm going to have 1 over 1 and 1 over 2. And we can have a plus or minus version. So plus or minus 1 and plus or minus 1 over 2, which is 1/2. And then I'm going to go with the 2 here. So that's going to be plus or minus 2 over 1, which is 2. And plus or minus 2 over 2, which is 1. We already have that, so I don't need to add that again. Then we go to the 3. 3 over 1 is 3, plus or minus 3. 3 over 2 is plus or minus 3/2. And for the last one, 6 over 1 is plus or minus 6. And 6 over 2 is 3, which we already have. So we see here that we have, 12 possible rational roots for this function. And those do correspond to our calculator, because if you look at the calculator, negative 2 is on there, and positive 3, and positive 1/2. So what I want to do now is, if we put this value into the function, if we get a 0, like a 0, that means that that is one of our zeros of the function, or x-intercepts. So now I'm going to go to my table, make sure that it's on ask and auto here. I did second window for that. And then I'm going to do second graph. That's my table. And let's do this from a different class. So let's just go ahead and, I didn't really write that in a good place, but we'll start with 1, -1. And we're looking for a y value of 0 over here. 1/2, 1 divided by 2. -1 divided by 2. And we've already found 1 at 1/2. And then we're going to have 2 and -2. 2, -2. And we found 1 at -2. And since I already know, we could try the rest of these, but I'm already pretty sure that 3 is 1 as well, because that corresponds to my graph that I had earlier. So there are my 3 roots. Now remember, this is a third-degree polynomial, so we can only have up to 3 roots. So really, that's kind of the answer to the question. Those are our 3 roots, and we found them all by using the rational root theorem and then plugging it into the equation. But let's just say we found one of them. Let's just say we found one of them and we want to find the other 2. Oops, what is that? Oh, close that. This is what we can do. And let me erase this so I have a little bit more space here. I'm going to take one of those. So I know that 3 is 1. And I'm going to do what's called synthetic division. And this is in chapter 3.2. So feel free to use that. And what you do is you take your root that you know that you have, which 3 is one of them. And then I'm going to put all the coefficients of the original equation there. So 2, -3, -11, and 6. And then I'm just going to do synthetic division. So you start by bringing this first number down, and then you multiply it by your root. So 3 times 2 is 6. Then we add these together. We'll get 3. And then we'll do 3 times 3, which is 9. Add those together. You get -2. 3 times -2 is -6. And add those together, and you get 0. And if you pick a number that is a root, you'll always get a 0 at the end. So if you don't get a 0 at the end, you either did something wrong here or you picked something that was not a root. And what this means is now I can write this 3 as a factor. The way that you write it as a factor would be x minus 3, right? Because if 3 is a factor, then, or 3 is a 0, then x minus 3 is your factor. And then the other polynomial is the one with these coefficients here with 1 less degree. So we're going to start with this one, 2. So 2x squared plus 3x minus 2. So that is now this is equivalent to our original equation. And then you can either factor this right here, or we can use one of those other roots to find the last root. So let's do that. Let's use synthetic division one more time. So I know that -2 was a root. So we're going to do -2. And we're going to do this equation here. So just use the coefficients 2, 3, and -2. I should get a 0 over here if I do it right. I'm going to bring down the 2, whatever's here. And then 2 times -2 is -4. Add those together, we're going to get -1. -2 times -1 is +2. Add those together, I get 0. So now I can write this as x minus 3 times x. If -2 is a root, then x plus 2 is a factor. Just think about it, because if we have x plus 2 is equal to 0, if we have that factor equal to 0, and we subtract 2 from both sides, we're going to get x is equal to -2, which is our root there. And then the last one here is going to be, we're going to do one less exponent than this. So this is going to be 2x minus 1 is equal to 0. And there you have it completely factored out. We have all of our roots. We can set this last one equal to 0 just to get that last root. 2x minus 1 is equal to 0. Add 1 to both sides. 2x is equal to 1. And then divide both sides by 2. And we'll get x is equal to 1/2. Now notice I did this in two separate ways, but if you can get all the rational roots from your calculator, you're fine. If you can only get one of them, sometimes that's good enough in order to figure out the others, because it's not going to give you the rational zero theorem is not going to give you any irrational roots. Irrational are mostly, when we talk about polynomials, either square roots, cube roots, things like that. It's not going to give you those. So in order to get those, we often just have to find one of the rational roots, get it down to a quadratic like this, and then use one of our many rules that we have for solving quadratic. Sometimes the quadratic formula, sometimes just factoring. There's sometimes completing the square. There's a lot of different processes for doing those. All right, guys. I hope everybody understood this. If you have any questions, please let me know. And I hope you all have a great rest of your week. Thank you.